Hello, Viduranga. How are you? I think you are fine. Right. We'll see seventh lesson. Quantification of elements and compounds. Right. Mm, right. Uh, First head topic is 7.1 relative atomic mass. It is symbolized as AR. See the assignment 7.1. Uh, in normal life, we buy something in different masses or different amount. In here, what are the units? To measure the mass of following things. A car, a loaf of bread, a molecule of carbon dioxide, a brick, and table of medicine, a helium atom. Right. Uh, some can have different some can have certain masses, right? Right. Here a motor car, a brick, loaf of bread, sometimes a tablespoon of medicine, like something in kilograms, grams, and milligrams. Here, small particles, right? That in here, loaf of bread, brick, it is large particles. Small particles here, a molecule of carbon dioxide and helium atom, it is a smaller amount. We cannot measure it from kilograms, grams, or milligrams, right? Then we use small masses. In here, very small masses, extremely small. What is even attogram? Attogram is the smallest uh, measurement. What is symbolized as AG? The smallest unit of mass is to large is indicate the mass of atom or ion. Right. One attogram is equal 10 to the power minus 18 grams. Right. In here example, right? The mass of atom of lightest element, you know, it is hydrogen. Hydrogen is 1.674 into 10 to the power minus 424 grams. It can like in this way in here. Masses of some other atoms are here, right? It is this hydrogen is lightest atom, right? We'll see other atoms in here, right? Mass of carbon, how is the grams? Then mass of sodium atom, then chlorine atom, then mass of potassium atom. Here the values. Right. Right. Here, these values are difficult to handling. In here, for this reason, the mass of selected atom was taken as a unit, and the masses of the other atoms were given relative to it. right? Select a atom and atom is how to relate to that atom. We take the other masses of the atom, right? Here we call that relative atomic mass, but is why relative to other that selected atom, right? Then relative atomic mass. What is relative atomic mass? The mass of expressed is known as the relative atomic mass. The relative atomic mass is not a true mass. It is not a true mass. Here is grams here. It is not true mass. It is not units. Why it is relative to other mass here, not a true mass of an atom of an element. In the past, the mass of an atom of hydrogen, the lightest element, was used to the atomic units, right? Past days, they use that helium. Helium mass. It is lightest element in the periodic table, and they take it. In nowadays, not hydrogen atom, we use that for that is carbon atom, right? Relative to carbon. How is the mass relative to carbon atom? First, they use hydrogen atom. It is lightest. It cannot get the idea, right? Then atomic mass unit. We use atomic mass unit. Atomic mass unit here. What is the unit? Here we use carbon isotope. Carbon, you know, there are two types of isotopes. Carbon 14-6 and carbon 12-6, right? Here we use 6-12 carbon, right? Then atomic mass unit. The mass of the unit relative to each the masses of other atoms are expressed is called the atomic mass unit. At present, 1/12 of mass. 1/12 the mass of carbon 612 isotopes is used to atomic mass unit, right? In here, atomic mass unit, right? Atom unit, right? First, 12th one in below, and mass of the carbon 612 isotopes. Here, carbon 612 isotopes mass is, it is given in the previous page. It is 9. It is 1.99 into 10 to the power minus 23 grams divided by 12. Here 12. Why we use 12? It is 12. This part we take here, and 12 in below, and 1 in above. Then we add the mass of 612 isotopes. It is 1.99 into 10 to the power minus 23 grams. Right? The answer is 1.66 into 10 to the power minus 24 grams. This is the atomic mass unit. Atomic mass unit. Atomic mass unit. We measure the other relative atomic mass. How many times of this unit? Right? Using this is the unit to measure the mass, relative atomic mass. Right. Here, how many times an atom? How many times an atom of given relevant weights as much as 1/12 the mass of carbon 12 isotope is the relative atomic mass of the element. Right? This is the definition. What is the relative atomic mass of the element? Right? How many times an atoms of given elements weights as much as 1/12 of mass of carbon 12 isotopes is relative atomic mass of that element. Right? This is the equation. We use this right. We use this equation for calculate the relative atomic mass of any other element. Right. Here we want to find out the relative atomic mass of the oxygen. Right. Here we use this equation. What is equation? Relative atomic mass. Symbol is AR. In upper part, mass of an atom of the element. Mass of an atom of the element. This is the true mass they given to us. This one, 1/12 mass of a 612 carbon atom. This is, we know that what is the value. It is this value, or 1.66 into 10 to the power minus 24 grams. Right? Here, how we calculate it. Here, true mass is they are given in 2.66 into 10 to the power minus 23 grams. That is the true mass of the oxygen. Then we want to measure out relative atomic mass. Relative atomic mass relative to the carbon 612 isotopes. Here, mass of an oxygen atom. Mass of an oxygen atom. Here, relative atomic mass of oxygen and here 112 and mass of a carbon 612 atom. Right here, we write here the true mass of oxygen, and this value is we can write in here this part, or can write this part. Only write only in this one, or other one this, right? And simplify it. Then answer is 16.02. You know, relative atomic mass of oxygen is we call 16. Here it is equal to that 16.202. Right. Then next page, relative atomic masses of some elements. Then you also know relative atomic mass. We want to calculate that relative atomic masses of the element. Sometimes you know about that. Here, in you know, you want to know 20 elements according to the periodic table. What is that? 1 to 20: hydrogen, helium, lithium, beryllium, carbon, boron, carbon, nitrogen, oxygen, chlorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. And symbols are here, and relative atomic masses here, right? Always we use in scientific measurement this relative atomic masses. Then you want to remember these atomic masses in your periodic table. That these 20 elements is there, right? Right. Here is an example. The mass of potassium. Potassium symbol is K. The true mass of potassium is 6.476 into 10 to the power minus 23 grams. The mass of the 612 carbon is mass. This is the mass of the 612 carbon. It is we know here it is 612 carbon mass, true mass of it, and it is divided by 12. We get the atomic mass unit. Right here, example. Right, we apply here true mass of potassium atom. They given here true mass of potassium atom, and the atom of carbon, and 12. See, here's the equation, and then simplifies that. The final answer is 39. Here, what is the relative atomic mass of potassium is 39. Right. Then other example. the mass of an atom of element A is 8 times the mass of carbon 612 isotope. Find the relative atomic mass of A, right? How we find out the relative atomic mass of A? Relative atomic mass of A, here the equation, we apply the data in it. Right. Mass of an atom is A. We don't know what is the true mass of element A. Right. Here we know this part. It is 12 in 1, and this is, you know what is this one? 1.99 into 10 to the power minus 23. Right. We apply that in 8 times this, and here also mass of 612 carbon atom, right? And we can cut out this to this, and 12 go outside, and 8 into 12, right? It is, answer is 96. Right. Then third question, mass of sodium atom. Sodium atom true mass is 3.819 into 10 to the power minus 23 grams. The value of the atomic mass unit is 1.67 into 10 to the power minus 24 grams. Find the relative atomic mass of the sodium. Right? We write the equation for relative atomic mass. The sodium, the true mass of sodium is applied here. This value. What is this value? We take in here I call you, we can apply this part or this part. In this question here, they apply last answer, 1.66 into 10 to the power minus 4 grams, right? The answer is, what is relative atomic mass of sodium is 23, right? We can see it is right. Here sodium sodium. The relative atomic mass is 23. Right here, relative atomic mass column and relative atomic mass is 23. Right? Right. That is relative atomic mass. Then atoms and only the element. We find out it using this equation. Then second part, 7.2, that is relative molecular mass. Relative molecular mass. That one, previous part, relative atomic mass. Right here, relative molecular mass. You know, atoms did not find freely in the environment. The atoms combine with other elements. The elements combine with other elements. Right here, since many elements are reactive, their atoms do not exist as free atoms. They exist naturally as molecules formed by joining two or more atoms of them. Compounds are composed for molecules formed by the combination of atoms belonging to different elements. Right? The compounds made out by combination of different elements using atoms. Right? Then molecular mass. Molecular mass. Previous session we take atomic mass in molecular mass by combine with two or more atoms in here, then produce compound, right? Compound mass. What is the relative compound mass or relative molecular mass? How many times a given molecule of an element or a compound weighs such as much as 12 the carbon, the mass of carbon 12 isotope is the relative molecular mass of the element or compound. Right here, relative molecular mass. Relative molecular mass. Here, the equation here, mass of molecular of an element of a compound. Mass of a molecule of an element Right. This is the equation, relative molecular mass. Symbol is MR, so capital M and simple R. Mass of a molecule of an element or a compound, uh, 112 into mass of a carbon, 612 atom. Uh, right. True mass. Here, true mass of the carbon dioxide. We want to find out what is the relative molecular mass of carbon dioxide in this example. The uh, relative molecular mass of carbon dioxide. The true mass of the carbon dioxide molecule is 7.31 into 10 to the power minus 23 grams. Right. Mass of the carbon atom. You know this value, mass of a carbon atom. It is 1.99 into 10 to the power minus 23 grams. Right. Here we apply the data. Here, mass of a molecule of carbon dioxide in the value is here, and 112, and mass of the carbon 612 atom. It is 44. It is 44. You know, we calculate in other way carbon relative atomic mass and oxygen. 2 oxygen is here. Two oxygen is, and we take 12, 2 oxygen. 1 oxygen is 16, 2 oxygen 32, and 32 add to the 12, it is also 44, right? Then it is relative molecular mass, does not have a unit. No units in this, grams cut by grams, not unit to relative molecular mass or relative atomic mass. There are no units. Right. Here, relative molecular mass of H2O, water molecule. Here, water molecule. The mass of a water molecule is 2.99 into 10 to the power minus 23 grams. Atomic unit is this value, and we apply the data here to the equation. Value is 80. Also, you can calculate this way. Relative atomic mass of hydrogen is 1, 2 hydrogen here, that is 2. Relative atomic mass of oxygen is 16. Then 16 add to 2, it is 18. Right? Then relative atomic mass of water is 18. Right? Right. If the molecular formula of an elements or compound is known, the relative molecular mass can be calculated. This is because the relative molecular mass is equal to the sum of relative atomic mass. Here, sum of relative atomic mass of the atoms in molecule. For example, water molecule has 2 hydrogen atoms and 1 oxygen atoms bound together. Therefore, the relative molecular mass of water is sum of the relative atomic mass of 2 hydrogen atoms and 1 oxygen atom. Right here is that. Right. Next page. Uh, Here, in this way, also we can calculate the relative molecular mass of water. And uh, uh, some relative molecular masses are given here. Hydrogen, right? Here, the example, you can study that. And exercise 1, you want to do that. And exercise 2, you can do it, right? That's time over, right? Do the exercises, and if you are any doubt, message to me. Right. Thank you.